Good afternoon, students. We are taking the session on vectors. So, before I start, just let me give you a piece of advice. Dear students, this is a mathematical subject where you need more practice, and it's a stage by stage learning. It's not at one time, okay? So, normally what you people do, the lateral entry students, you study mathematics at the end of the semester. So, it is not like that. You have to study from the beginning. So, like it's not that one day you can study the entire syllabus, right? So, I see students, some of the students, they come to me, okay. So, what they do, just previous day of the exam they will come, they will ask me, ma'am, you teach only 2 units. So, is it possible to learn in one day? So, it is not possible to learn the entire unit in one day or 2 days, right? So, we need a periodical study. So, you cannot study at a stretch. So, what I suggest is, as a student, what you do, you study for 2 purposes. What are those? One, either it is for knowledge sake or it is for examination, right? So, you need to complete a degree, so you have to face the exams. So, when you face the exams, what you do? You study for examination point, but that is not the way you learn. So, what you have to learn is, as a knowledge also you have to study, and as for the exams also you have to prepare, right? So, but when you prepare for the exams, how do you prepare? Just not that you mug up and go, right? So, it is not the subject where you can mug up in one day and face the exam in the next day, right? Now, you have to study these subjects, especially mathematical subjects. So, what are the subjects related to maths, right? So, you have to study in periodically, right? Gradually you have to study. It is not that one day you can complete the entire syllabus. So, what I suggest is, start studying at least from now onwards. So, when you come to face the exam, so you will be confident to write the exam, right? So, do not neglect this subject, because you can do it in till 8th sem. So, it is not so. So, take it and finish it in first and final attempt. First attempt you have to finish. So, this is possible provided you have to make up your mind and learn it. It is really easy, and VTU is supporting you by telecasting these live classes. Even the video is available in the network. So, you can always take that, download that, and you can see the videos, right. So, this with this brief advice, just let us recall the topics whatever we have learned till today. So, I told you, right. So, we cannot study at a stretch. So, till now whatever we have cut, just let us take a swift look at this. Now, if you remember, we started with the vectors. Now, if you see the screen, right, vectors we have, how we will denote the vectors. It's a simple vector, right, a1i plus a2j plus a3k. So, it's a basic, very basic of the vectors. So, if you remember, these we studied in the basic classes like numbers a1, a2, a3. Now, based on this we defined what is magnitude. So, magnitude of a is what? Square root of a1 square, a2 square plus a3 square. Now, this plays an important role in our topics, unit vector. So, what is a unit vector? Let it be any vector. So, how do you define a unit vector? A cap is vector A by its magnitude. Dear students, pay attention to these small definitions where it is most helpful in all the topics. Now, what is this? A cap is equal to vector A by its magnitude. So, we know what is the magnitude, right? Now, based on this we define what is the dot product. So, I keep repeating this whenever we take the dot product between 2 vectors. So, what will be the resulting answer? The resulting answer will be always a scalar, right. So, these are some of the basics we learnt in the class. Just let us look with this again some of the other definitions. So, we had defined what is a cross product. Again, how it is defined? The first row is a determinant, first row is I, j, k, second row are the components of A, the coefficients of I, j, k, a1, a2, a3. Similarly, the third row will be the coefficients of B, the vectors components of B, B1, B2, B3. So, when you simplify this determinant, what you get? Is it a scalar or vector? So, definitely it is a vector, because it includes I, j, k, right. So, cross product is always a vector and dot product is always a scalar. Now, check this angle between 2 vectors. So, it is given by cos theta is equal to a dot b by its magnitude, the dot product by the magnitude of individual vector, right, a and b. Now, these are some of the basics. If you remember, definitely you can solve other problems, right. Now, this was the basic vectors, right. Now, with these what do we get? We can always say that 2 vectors intersect at 90 degree when theta is 90 degree. So, using that cos 90 is 0, therefore, your a dot b will be 0. So, condition for to show that 2 vectors are perpendicular. So, it is enough if you show that the dot product between these 2 vectors are 0. So, these are some of the basics which always you have to remember. Now based on this concept of vectors, we define what is a position vectors. So from now on, from this onwards, you have to remember properly, thoroughly. So what is this? R is equal to xi plus yj plus zk. Remember students, always the moment we write R, you should imagine that it is nothing but what? Xi plus yj plus zk. And based on this, we define what is a velocity. V is equal to dr by dt. Then acceleration, a is equal to rate of change of velocity, it is d square r by dt square. So we solve some of the problems on this. Then we define what is a scalar point function. So see here, look at the function. It is phi is equal to x. I am just giving you an example where this doesn't have the unit vectors I, j, k. Now similarly, we defined what is a vector point function, which has a arrow indicates that vector, it's a vector. So it is represented like this. So it should be clear what is a scalar point function, what is a vector point function. So based on these two definition and some of the operators, right? So we define some of the operators. What are those? This del or nabla we call. So it, in vectors, we denote always, the moment we write del, it is nothing but this is the operator. See, it's just an operator. There is no function in this. It is only dou by dou x is an operator into I, dou by dou y j, dou by dou z k. So what are these dou by dou x, dou by dou y, dou by dou z? These are the partial derivatives. Then Laplace operator we have del square. So again this is a scalar, dou square x by dou x square, dou square by dou y square, and plus dou square by dou z square. So this is the other operator. So these two are the operators, are the important operators. Now based on this, we define some of the terms like gradient of phi, gradient of a scalar function. So in future, whenever we denote phi, it is a scalar function. Grad phi is nothing but, how do you define this? Either we denote like this, grad, grad, grad phi, or del phi. So how it is defined? Dou phi by dou x I. So differentiate phi with respect to x into I, then differentiate, that is partial derivative, dou phi by dou y into j plus dou phi by dou z into k. So what are these? These are the partial derivatives. Dear students, these partial derivatives are easier than your ordinary derivatives. It's very simple because we treat the other variables are constants. See, suppose if I differentiate with respect to x, what do you treat x, y and z as? Constants. Similarly, when I differentiate phi with respect to y, we treat x and z as constant. So same way you can extend it to any number of variables, right? So it's a very simple definition of grad phi, and it's very important from the examination point of view, because there will be certainly a question on this grad phi. And do you remember we had a geometrical meaning of grad phi? So what does grad phi represent? Grad phi represents a normal to the surface, right? So based on that, we define a unit normal vector, that is n cap, grad phi by its magnitude. Always any unit normal, it is nothing but vector by its magnitude will give you the unit vector. So these are some of the basic definition which you have to give importance and learn this. So n cap is nothing but grad phi by magnitude of grad phi. And you remember, and again this is an important definition, what is that? The angle between two surfaces. So if phi 1 and phi 2 are the two surfaces, the angle between these two surfaces are nothing but angle between their normals. And we have shown already in the sum theorems that grad phi always represented normal. Therefore the angle between two surfaces will be what? Grad phi 1 dot grad phi 2 divided by its magnitude of both the vectors. So this is an important relation with this. So please remember, so what you should do as a student, what are the formulas or definition you learn, please keep writing, don't read. So when you remember its physical or geometrical meaning, it is very easy to solve the problems. So what is that you have to remember? Grad phi represents the normal to the surface, and we know the definition of grad phi. So these are the two important definitions which you have to remember. Now in today's class, let us define based on the grad another definition, what is known as directional derivatives. The name itself suggests directional derivatives. It gives the direction. So if you want to remember, so let us first define this. So if phi of x, y, z is a scalar function. So throughout our sessions, we denote in almost all the textbooks, we denote the scalar function as phi. So it is a function of x, y, z. If phi is a scalar function and d is a given direction, the vector d is a given direction, then this dot product, so dot product of grad phi and n cap. So what is n cap? N cap is the unit vector of vector d. So how it is defined? D vector d by its magnitude. So the small definition, what is this? This is the directional derivative of phi along n. So if you remember, any vector in the direction of other vector is always given by, suppose a and b are two vectors, what is the vector a in the direction of b? It is a dot b cap. Same way, we need the directional derivative of phi in the direction of n cap. So therefore we always get the dot. So whenever we want any vector in the direction of other vector, we take the dot product between them. One of them with the wherever the direction is required, that will be a unit vector. So we have grad phi in the direction of d, which is nothing but grad phi dot, the unit vector in the of d is denoted as n cap. So this small definition, that is grad phi dot n cap, is nothing but the directional derivatives. So in today's class we will be concentrating on this directional derivatives. So which is an important topic again from the examination point of view. So definitely there will be a question on these definitions, right? Directional derivative. So remember, grad phi dot n cap. So how do you solve the problems on this? Suppose the last, find the directional derivative of the given function in the direction of the given vector. So it's very simple. So the definition itself indicates we need only two terms, two terms, right? One is grad phi, other one is n cap. So when phi is fixed, grad phi is fixed. So this part you need not have to worry. So what is this? Grad phi will be, a phi function is given, just find grad phi. So this term is always easy to find out. When you find this n cap, so it depends on what type of question they have asked, n cap, right? So please always read the question carefully when you answer these type of questions. So what is that? We need to find the directional derivative. A surface is given, that is phi of x, that is scalar function is given, and a vector is given. So we will be finding only this dot product. So let us take the example and learn how to find directional derivatives. Now let us take the problem, right? So let me explain on the screen only. Find the directional derivative of phi is equal to, so what is the function? X square yz plus 4xz square at the point 1 minus 2 minus 1 along 2i minus j minus 2k. Now directional derivative. So what does basically, when you read this, you should remember the definition. Directional derivative is given by what? Grad phi dot n cap. So we have phi. So let us find, see, always in maths, always you should, before starting the answering the question, you should think, just spend few seconds on what are the required things, right? So you should prepare first. So what is given, what you have to find, right? So that's the only basic things you should always analyze when the problem is given. So what is the first thing you have to do? Check what is given. What is given? Phi, that is a scalar function is given to you, right? So you have to find the directional derivative. So the moment directional derivative, just recall what's the definition of directional derivative. So what's the definition of directional derivative? Grad phi dot n cap. So we have phi. So what you have to find? Grad phi. So let us, what we do? So always do it stage by stage. Don't think overall everything at one stage. So let us first, what we find? Grad phi, let us find. So we know the definition of grad phi. See that grad phi includes what? The derivatives. So sometimes what happens, you'll get confused. What is directional derivatives? What is normal, right? So you should keep some hints to remember the formulas. So how do you remember this formula now? See, grad phi includes derivatives. Therefore it is derivatives. Then direction is given by unit vector n cap. Therefore directional derivatives means grad phi dot n cap. So always see, whenever you have to remember, see it, if you are facing the exam, you have to remember, right? Certainly you have to keep everything in your memory, and there will be lot of definitions, lot of formulas to remember. So you have to always keep certain hints to remember these formulas. So how do you remember this now? Directional, it's just a thing based on the definition, right? So I have direction. So direction means n cap, and derivative means, see, this grad phi includes derivatives in the definition. So remember like that, directional derivatives means what? Grad phi. So see, either a dot b is same as b dot a. So therefore you can take in any order, grad phi dot n cap or n cap dot grad phi, okay. So remember in the same order, directional. So n cap and derivative is grad phi. So directional derivative is given by grad phi dot n cap. Now let us find out what is grad phi, right? So we have the basic definition of grad phi. So, what is the definition? Dou phi by dou x into I plus dou phi by dou y into j plus dou phi by dou z into k, right. Now, let us find out what is this function now. Now, dou phi by dou x, take this phi, differentiate partially with respect to x. Now, the moment you see the derivative with respect to x, now what are the other two variables? Y and z. So, we have to treat y and z as constant. It is same as your ordinary derivative, only thing is there will be more number of variables. So, you should be a bit careful when you differentiate. Now, what I suggest is, when I am differentiating with respect to x, observe the function first, do not directly write, just observe for say a few seconds or a fraction of a second, right. Now, what do we have there? See, in this term x is there, in this term x is there. So, we have to differentiate both the terms, right. Now, what are the variables we are going to treat it as constant? Y and z. So, when you differentiate with respect to x, what you do? First write yz, okay. So, because it is a product, yz is a constant, then what you have to differentiate? We have to differentiate only x square. What is the difference of x square? 2x. So, always see one way of, it's like I always tell my students that maths is an art of simplification. So, you should know how to simplify. Okay. See, if I write ABC in one term and BCA in one other term and CBA in other term. So, when you observe, suddenly what will happen? It looks as if all the three are different. So, always in maths, remember, when you are writing the expression, we follow some particular order, right. First sign, if there is a negative sign, then the number, then alphabetical orderly you write. So, x, y, z. When you simplify, it will be easy to simplify that, okay. So, these are some of the fundamentals always you have to remember when you solve any mathematical questions. Now, what did I tell? Now, dou phi by dou x. So, yz is constant, differentiate x square. So, 2x yz plus, because this also includes x, so 4z square is constant, differentiation of x is 1. It is very simple, this partial derivative. So, do not worry looking at the notations, right. So, it is a very simple notation, dou phi by dou x. So, differentiate this now into I. So, what you have done? We have find the partial derivative of phi with respect to x. Now, we have a plus sign. So, put that plus sign. Now, what do we need? We need dou phi by dou y. So, immediately what you should observe? Check where y is present. See, just observe this. Y is present only in the first term. Second term, do not include y. So, therefore, what is that second term? When you differentiate this function with respect to y, so this 4 is constant, x is constant, z is constant. So, totally this term is constant. Therefore, what is the differentiation of this term? The differentiation of this entire thing is treated as constant now. Therefore, differentiation of this term will be 0. So, what is that next then? For this term, what do we get? When you differentiate this with respect to y, x square z is constant and differentiation of y with respect to y is 1. Is that not simple? Right? So, its only thing is you need to practice. Plus, similarly, find out dou phi by dou z. So, how do you find dou phi by dou z? Again, look at the expression. So, z is present in the first term, z is also present in the second term. So, therefore, let us differentiate both the terms. Now, what is that? X square y is constant, then partial derivative of phi with respect to z is 1. So, get x square y plus. So, 4x is constant, differentiation of z square is what? 2z. So, 2z into 4x will be 4 2s are 8 xz, xz. So, there is no y here, sorry. So, there is no y here, so it is only 8 xz, okay. Now, just observe. So, this is the expression for del phi. Now, what is the question? Find the directional derivative of this function at 1 minus 2 minus 1. So, we got the expression for grad phi. So, this is the expression, this where this y is not there, okay. Now, at this point, we have to evaluate grad phi. So, whenever we have 3 order triplets, so what is that? So, this is value of x, this is the value of y, this is the value of z. Now, substitute the value of x equal to 1, y is equal to minus 2, z is equal to minus 1 in this expression. So, when you simplify this, substitute and simplify, you get the vector as 8i minus j minus 10k. So, see that since the point is given, grad phi is no longer in terms of x, y, z. So, instead of x, y, z, we have substituted the values. So, we have a vector which is where the coefficients of I, j, k are some numbers. So, this is the grad phi. Now, what you have to do? So, what is the 2 stages you have to remember? we need to find grad phi, and other one is what? N cap. So, we got the first term which is grad phi, right. Now, let us check the unit vector. So, just observe what is that? Along 2I minus j minus 2k. So, we need to find the unit vector of this vector, right. So, let us find that. Now, the unit vector in the direction of 2I minus j minus 2k is, so what is that unit vector now? So, how it is defined? Vector by its magnitude. Magnitude is nothing but square root of a1 square plus a2 square plus a3 square. a1 square is 4, even though a2 is minus 1 whole square is plus 1. Similarly, a3 is minus 2 whole square is plus 4. So, when you add up all this, it becomes 9, square root of 9, which is 3. Now, what are the two things we needed? Grad phi and n cap. So, we have grad phi value, so we have n cap value. Finally, the directional derivative is given by grad phi dot n cap. So, we got the value of grad phi 8I minus j minus 10k dot n cap. So, n cap is here. So, take the dot product between these two. So, this is a scalar, so it will be remaining as it is. So, take the dot product, 8 2s are 16, minus 1 into minus 1 plus 1, then minus 1 into minus 2 plus 20. If you simplify this, you get the directional derivative as 37 by 3. So, see that it is a dot product between two vectors. The final answer is a scalar. So, always in maths, you can always verify the steps. So, whether the final answer, sometimes what happens, somewhere it will go wrong, right. So, always make sure you verify your answers. Now, grad phi dot n cap will be a scalar. So, dot product from these two vectors is a scalar. So, dear students, basically what you have to remember, the moment you see directional derivative, remember it is the grad phi dot n cap, and always go stage by stage. See, do not go wrong in the first step. So, what we need? We need grad phi. So, to find grad phi, what we need again? We need the function. So, find the grad phi. So, keep it aside. Then what we need the second part? We need the unit vector. So, definitely a vector is given to you. So, find its unit vector. Take the dot product. So, always you have to remember this flow chart. When you go it in the order systematically, definitely you will not go wrong. Now, similarly, let us take up the other example. So, the more number of problems you solve, it will become more thorough, right. So, we have the function phi, which is given by 4xz cube minus 3x square y square z at this point along the vector 2I minus 3j plus 6k. So, based on the same like last example, so define, always write the definition. So, this carries 1 mark. So, at least some marks is allotted to this, right. So, grad phi is this vector, then find out dou phi by dou x, phi is this term, phi is this term. So, x is present in both the terms. So, therefore, we will be differentiating both the terms. So, 4z cube is constant, differentiation of x with respect to x is 1, and similarly here 3y square z is constant and differentiation of x square is what? 2x. So, 2 into 3 is 6 x y square z. So, always remember, write in a particular order, so that it will be easy to simplify. So, first constant 3 2 is 6, 6x y square z into I. So, this entire thing is the partial derivative of phi with respect to x. Similarly, dou phi by dou y. Now, just check, observe the function, right. So, y is not present here, therefore, this entire term is 0, and what happens to this? This term y is present. So, therefore, differentiation of this will be 0 minus. So, 3x square z, since it is a product, keep it aside, 3x square z. What is the differentiation of y square? 2y. So, into 2y, this entire thing into 2y will become what? 3 2s are 6 x square y z into j. So, it is a simple partial derivative. See, the function may look a little difficult for you people, right, but the derivatives will be always simple. So, you should always analyze what is a constant and what is a variable. Now, similarly, when you differentiate with respect to z, what you should observe? Check whether z is present in both the terms. Yes, it is. So, therefore, what we have to do? Differentiate both the terms. Now, differentiation of z cube is what? 3z square. So, 3 when you multiply it to 4, it becomes 12x z square. So, that is what we have the first term. Now, check the next term. Now, 3x square y square is constant. So, what is the partial derivative of z with respect to z? It is 1. Therefore, what do you get? 3x square y square. So, totally we got all the derivatives. So, finally, grad phi is this expression. Now, first step is this grad phi. Now, but what is that they are given? We need to evaluate grad phi at the given point 2 minus 1 2. So, what you are going to do now? Substitute the value of x as 2, y as minus 1 and z as 2. So, when you substitute this, it gets simplified to 8i plus 48j plus 84k. So, keep on recalling grad phi is a vector. Now, what is that next thing we need? So, there are two stages here. What is that? One to find grad phi, other one is to find n cap, unit vector. So, already they are given the vector directly. So, just find the unit vector. So, what is the unit vector? So, this vector divided by its magnitude. Magnitude is what? 2 square is 4, minus 3 whole square is plus 9 and 6 square is 36. So, when you simplify this, you get 7. So, we got the value of grad phi and we have got the value of n cap. So, what is that final thing we have to do? So, just take the dot product between these two vectors. So, dot product is always we multiply the respective coefficient of I, j, k. So, 8 into 2, 48 into minus 3. So, always whenever there is a negative sign, you should take care of this sign. Okay, 48 into minus 3, then 8 into 6. So, totally when you multiply everything, so you get 376 by 7. So, dear students, it's a very simple definition, and many times they will be asking the questions on these type of problems, right. So, now what are we have solved? The two questions are similar, only I gave the function different, right. Now, there will be sometimes what they will do is, they will just change certain part of like that n cap, the direction. So, phi will be fixed, okay, they cannot change phi. The direction will be always, sometimes they will change that part. So, let us see how when we get this type of question, how to solve these type of questions, right. Now, just read the question. Find the directional derivative of phi. So, we have a function at the point 1 minus 2 minus 1. So, it is like similar to the previous problems in the direction of normal to the surface. So, they given one more surface and at that point is what? At what point? Minus 1 to 1. So, now what you should do? Break the question into two parts, split it up. What is that first thing? Phi is given, point is given. So, what we can find? Grad phi definitely surely we can find easily, right. So, at least that part you should not go wrong, right. So, we have a phi, we have this. So, let us do, what we do? So, we are at the question, right. So, sometimes you will not understand the complete question. What you have to do? Split the question into two parts. Okay, what is that first thing? Understand what we have to ask, what we have to find. So, what is that we have to find? Directional derivative. So, immediately what you should get in your mind? Grad phi dot n cap. So, see n cap they are not given directly. So, let us think later on. What we do first? Let us see, I can find grad phi without find any mistakes, right. So, let us do that. Let us find grad phi. So, first let us find the grad phi for this. Now, what is that given? So, for the given function, so what happens? So, I am writing it directly. Grad phi is this y square I plus 2xy z cube. So, we get this when you find out the partial derivative of phi with respect to x, y and z. Okay. So, we have these terms. Now, what is that they are given? At 1 minus 2 1. So, therefore, what will be grad phi at 1 minus 2 and minus 1? So, you get a simple vector 4i minus 5j minus 6k. So, what is that we have got? Grad phi at this point we have got the value. Okay. So, check the question. So, the first part is done. What is that first part? Grad phi, we are through with that, right. Now, let us leave that there. What is the next question? The next part of the question, in the direction of normal to the surface. So, what is the difference between the previous question? The previous question is what? They had given the vector, directly they had given the vector there. Here, they are not given the vector, but the direction they have mentioned it as something else. What is that something else? That is normal to the surface. Now, recall back, what is the normal to the surface given by? Suppose this surface is phi. Phi or psi, you can denote it in any term. Suppose if I denote this as a psi. So, what is the normal to the surface given by? Do you remember when we defined grad phi? So, we gave the geometrical meaning of that. Grad phi is the normal to the surface. So, that is the reason always when you learn something, remember its physical, that is the geometrical meaning, it will be easy to solve. So, what is that we are given? Normal to the surface. Suppose if I consider this surface as a psi and I want to find the normal to the surface, and we know that normal is nothing but, normal to the surface is nothing but, it is given by grad phi. So, let us check what is that we have to find. So, what we do now? Let us, because already we have denoted the first function as phi, let us denote this next function as psi. Psi is equal to x log z minus y square plus 4. This is the given function. This 4 on the right hand side, we have brought it to the left hand side. Okay. So now what is that we have? We have the function, other function. Now in the direction of normal to the surface, and what is that normal is given by grad psi. So this gives the normal to the surface. So what we do? We find grad phi for this function, grad psi for this function. Now what is dou psi by dou x? So again look at the function x log z minus y square plus 4. So where x is present? X is present only in the first term. The remaining two terms there is no x, therefore it is a constant. Now let us differentiate this. What do you get? Dou psi by dou x will be equal to log z is constant, differentiation of x is 1. So therefore log z into I, then what is that? Dou psi by dou y. See, y is not present in this, y is not present in this, therefore differentiation of this with respect to y is 0, minus differentiation of y square will be 2y, then this is 0. Okay, therefore finally we get minus 2y. Now here dou psi by dou z. So what we do? We treat x and y as constant. So this is constant, this is constant. So z is present in this term, x is treated as constant. So differentiation of log z is what? 1 by z. So therefore it is what? X by z. So we had a new surface, that is psi. We got its normal. Normal is nothing but grad psi. So always when you revise, students, make a note of these things. So what is that? Grad psi represent a normal to the surface. Now, so we have grad phi, we have grad phi, and we have grad psi. What we need? We need the directional derivative of, that is grad phi, in the direction of normal to this surface. So normal you have got. So what is the unit vector in this direction? Let us find the vector normal to the surface. So we at this point let us find out minus 1, 2 and minus 1. So let us substitute in this. We get minus 4j minus k, the ith component will be 0. So let us find out n cap, minus 4j minus k square root of root 17. So what is that we need for directional derivative? We got the expression for grad phi, and we have the vector, unit vector n cap. So therefore what will be the directional derivative of phi? In the direction normal to the surface, psi. So it is given by what? Grad phi dot n cap. So take the dot product between these two. So you'll have a doubt. See, I is not present here. So what you take the coefficient of I? The coefficient of I will be 0. So 0 into 4 is 0. Minus 5 into minus 4 is 20. Minus 6 into minus 1 is plus 6. So 20 plus 6 will be 26 divided by root 17. So students, let them give any questions. Only thing is, you just read the question twice, read stage by stage. Whatever you follow, please do that first. Don't get confused, because it's not at all tough. Only thing is, keep the geometrical meaning remembering. So you should know what is the geometrical meaning of grad phi. Now let us take, see we are learning what? Only directional derivative. See what are the different types of questions you can expect. Now what is the next question? Just see how it is different in it's a different from the first question, second question and third question. So what is that we have? Find the directional derivative of, definitely they are given the function. See, instead of phi, what they are given? It is f. So okay, so let them give any function. What is this? This is a scalar function at the point. So they are given the point in the direction of the tangent to the curve. See, what was the previous question? It was normal to the curve. Now it is normal to the surface. Here in the direction of the tangent to the curve, they are given the curve. So what I suggest is, check the question, directional derivative. So directional derivative is immediately what you should know, grad phi dot n cap. So grad phi, instead of phi we have f. So definitely we can find grad f, right? Now what's the next part we need? N cap, that is unit vector in the direction of the tangent to the curve. So the moment I gave tangent, so what's the meaning of tangent? How do you obtain a tangent in the vectors, right? So we have defined, remember, position vector r, and its derivative with respect to t will give you the tangent to the curve. So let us see how to find this. Now first what we do, as I said, now first part let us finish. What is that? Given a function, the scalar function, let us find its grad f. So grad f is nothing but the same definition. Instead of phi we have f. So everywhere you get f. Now what is that? Dou f by dou x, dou f by dou x. So y and z is constant. So differentiation of this term with respect to x will be 2x y square z square into I plus, when I differentiate with respect to y, x and z is treated as constant. So, these two will remain as it is. Differentiation of y square is 2y. So, always write in the order number first, then x, y, z alphabetically. So, what do you get? 2x square y z square into j plus, similarly dou f by dou z, dou f by dou z. So, what is the partial derivative of this? 2x square y square is constant, differentiation of z square is 2z. So, finally it will be 2x square y square z. So, we got the value of grad phi, but at this point we need to evaluate. So, substitute x equal to 1, y equal to 1, z is equal to minus 1 in this expression. So, the resulting solution, the resulting answer for grad phi will be 2i plus 2j plus 2k. So, this is the first part of the directional derivative. So, we got the grad phi. So, always do it stage by stage, definitely will not go wrong. Then, what is the next thing? The next thing, along the tangent vector to the curve. So, they are given the value of x, y, z. Dear student, if you observe the question, in the direction of tangent to the curve. See, all this time we used to have a single curve, right? Now, what they are given? It is given in the parametric form. X is equal to e power t, y is equal to 1 plus 2 sin t, z is equal to t cos t. So, what do you observe? So, there is x, y, z as well as there is a variable t. There is a one more variable, right? So, x, y, z all are functions of what? A single variable t. Now, how do you combine everything? X, y, z now. So, just see this. See, this is the basic definition of our position vector. So, r is equal to xi plus yj plus zk, and you should remember x is a function of t, y is a function of t, and z is a function of t. So, what we do now? We know the value of x, y, z from the given question. So, substitute what is x, y and z in r. So, x is e power t into I, y is 1 plus 2 sin t, j plus z is t minus cos t, j. Sorry, this is k. Make this correction. This is a j. This is k. Okay. Now, what is that? What is that we are going to do now? So, we have written what is the value of r. See, now that given independently the value of x, value of y, value of z, but we didn't add the equation there. See, now we got the term expression for r. So, with all the plus and minus signs, right? So, e power t, all the expression, it is a vector. Now, what is the tangent vector? Tangent vector is given by dr by dt. So, let us, why this ordinary derivative now? Just observe. See, sometimes always when you understand, there will not be any confusion, right? Now, why it is dr by dt? See that everything is a function of, the right hand side is a function of single variable. When there is a single independent variable, we get ordinary derivative. Students always understand these things. It's not that if you solve 100 problems, you will understand, okay? Please give importance for the basics. So, when we have a function with respect to only one independent variable, we always denote that as a ordinary derivative, which is denoted as what? Small d. If it is function of more than one independent variable, we denote that partial del or partial d. What is that? Del notation, dou by dou x, like that, okay? So, understand the difference in the notations. See, the moment I have a function r, which is it's a function of how many variables now? It's only one variable. Therefore, what do you get? Dr by dt. So, it's very easy to differentiate now. It's ordinary derivative. So, differentiation of e power t is e power t, and differentiation of 1 plus 2 sin t. 1 is a constant. Differentiation of 1 is 0. 2 into differentiation of sin t is cos t into j, plus we have to differentiate this bracket. Differentiation of t is 1 and cos t is what? Minus sin t. So, already one minus sign is there. So, what will happen? Minus into minus will be plus. So, finally, what we get? dr by dt equal to e power t into I plus 2 cos t into j plus 1 plus sin t into k. So, what is that we are doing? We are finding the directional derivative, where the first part is grad phi, which we already have the value here. And what is that? In the direction of tangent to the tangent. So, tangent we are finding. So, always the tangent vector is given by dr by dt. So, you should remember this. Tangent vector is given by dr by dt. And what is the normal to the surface? Normal to the surface is what? Grad phi, right? So, certain small definitions you should always remember. Tangent vector is dr by dt we have found. So, we have grad phi. So, let us find the directional derivative. Now, before that what will happen? Just observe. Before finding, see this is totally evaluated, right? It's in purely in terms of numbers. Now, if you observe this, if you observe this, this is still in terms of t. So, you have to find the value for t. So, let us see how to find the value of t. So, they are given at the point x is equal to 1, y is equal to 1 and z is equal to minus 1. And we know the value of x as e power t, which is equal to 1. The value of y is 1 plus 2 sin t and they are given it as equal to 1. So, let us equate those, the coordinates values, right. And similarly, the z is t minus cos t and the value of z is minus 1. So, just observe e power what is 1, e power for what value of t, e power t is 1. So, definitely if you remember e power 0 is 1. So, therefore, we can take the value of t as what, 0, or if you can't do that, check the other expression 1 plus 2 sin t equal to 1. So, this 1 and 1 will get cancelled. So, what will be remaining, 2 sin t equal to 0, right, 2 sin t equal to 0. So, therefore, what will be sin t? Sin t is 0. So, for what value of t sin t is 0? For sin 0. So, therefore, what do you get? What do you get here? Sin 0. So, again t is 0. So, you can find for all the from all the three expressions. So, you get the same value of t. So, t is equal to 0, right. Now, what we do now? Let us find the value of dr by dt at t equal to 0. From where did you get this? By solving from the given expression. We had the value of x equated to x coordinate, we had the value of y equated to y coordinate, we had the value of z equated to the z coordinate, and find out for what value of t this will be satisfied, which is nothing but t equal to 0. Now, find out that is tangent vector at t equal to 0. When you substitute t equal to 0, in this what will happen? E power 0 is 1. So, 1 into I plus cos 0 is 1, therefore, it will be 2j plus here what will happen? 1 plus sin 0 is 0, therefore, 1 plus 0 is 1. So, therefore, what do you get? What do you get? Just check I plus 2j plus k. So, this is the tangent vector. So, we got that n, that d, the vector d we got, right. Now, what is that we need to find? Its unit vector. So, let us find the unit vector. N cap will be, so this divided by its magnitude 1 square plus 2 square plus 1 square, which will be 6. So, finally, we got the value of grad phi and n cap. Therefore, the required directional derivative will be of the given function along the tangent to the curve is grad phi dot n cap. So, take the dot product between these two vectors, which is nothing but 4 by root 6. Now, dear students, always understand the basics concepts. So, definitely you can solve any question, let them twist, let them give it directly, definitely it will be easy to solve. So, what you have to remember is, what is the definition for grad phi, what is its geometrical interpretation? Grad phi is always the normal to the surface. And what else you have to remember? How to find the unit vector. Unit vector is n cap. And what is the other thing you need? Suppose it is the tangent vector, which is dr by dt. So, please remember the geometrical significance. Definitely you can solve any type of problems. Now, let us take some more examples. I will explain the board. So, just take the simple example. Find the directional derivative of the given function. Just check the function xy plus yz plus zx at the point is given in the direction of the tangent to the curve. So, there is some minor changes in from question to question. What is that? In the previous question, they are given explicitly x equal to y equal to z equal to. Instead of that, what they are given? One step ahead, that is they are given the value of r. That is the difference. Okay. So, read the question. What's the first question? What you have to find? Always let it be any question, anywhere, any in the any subject. First, you should always take what is given. So, you should understand the question. What is given? Function is given, point is given. So, what can I find? We can find the grad phi. Okay, the first part is done in the direction of the tangent to the curve. So, how do you find the tangent? That let us see. Okay. Now, let me explain it on the board. Now, what is that we are given? We are with, what is that we are given with? They are given the function. So, normally the scalar function we denote it as phi. So, let us take that xy plus yz, right, xy plus yz plus zx, correct. So, this is the function. So, they are given the point. So, let us take that point later on. So, what we need to find? Grad phi. So, always write what is given, then what is that we have to find? We have to find the directional derivative, for which we need. So, if one write that term, so we need the directional derivative, correct? So what is that we need to find? Grad phi dot n cap, correct? So write the definition. So we'll get to know what we have to find. So this function is given, we have to find the directional derivative grad phi dot n cap. So what are the two things we need? Grad phi and n cap. So let us find one by one. Now first let us find grad phi, right? So immediately the moment I write grad phi, it's a derivative, some int you have to remember. So write this, dou phi by dou x I plus dou phi by dou y j plus dou phi by dou z k, right? Now write this definition. See, always the definition carries some marks, okay? So this is the basic definition of grad phi. Now what you have to do? You have the function, let us find its derivative. So I have to differentiate phi with respect to x. Now immediately you should observe, right? X is present here, x is present in the third term, second term there is no x. So let us differentiate this with respect to x. When I differentiate this with respect to x, I get y plus. So from this term there is no x, therefore no, it's a constant, right? Therefore it will be 0 plus, and when I differentiate this with respect to x, it will be z. Z is a constant, right? Just check that. See, when it looks simple, but if you don't pay attention, what will happen? Some terms you miss, okay? First observe where x is present. X is present in both the terms, so we get sum of two terms, okay? So this is constant, y and z is constant. So this into I plus dou phi by dou y. Again observe where y is present in the first and second term. So the differentiation of first term, x is constant, differentiation of y is 1, similarly plus z is constant, correct, and differentiation of y is 1 into j, correct, plus, now what is the next term? We need dou phi by dou z, dou phi by dou z. Again observe what we have, z is present in two terms and this term there is no z, therefore this entire term is treated as constant, the derivative of that term will be 0, then differentiation of this with respect to z is, y is treated as constant, differentiation of z is 1 plus, again what is treated as constant there, x is treated as constant, differentiation of z is 1 into k. It's very simple, that too when you have partial derivatives, right? So just check, it's a simple expression. Now we got the expression for grad phi in terms of x, y, z. Now what I need to find? I need to find at 3, 3, 5, minus 4. So therefore what will be grad phi at this point? Just check, I got the expression for grad phi. We need to evaluate this at 3, 5, minus 4. X is 3, y is 5, z is minus 4. So let us substitute. X is 5, sorry, y is 5 and z is what? Minus 4. 5 minus 4 plus x plus z. X is 3, z is minus 4, j plus y plus x. Y plus x is what? 5 plus 3 into k, correct? So what do you get here? 5 minus 4 is 1, that is I, 3 minus 4 is minus 1 j, then 5 plus 3 is 8, 8 k. Now just check, is that not simple? It's a very simple derivative, only thing is you need to remember the definitions. So we got the value of grad phi, which is I minus j plus k, okay? So let us call it as 1, right? So we got the expression for grad phi. Now go back to the question and read, what is that? Find the directional derivative for this function in the direction of tangent to the curve. So what is that curve? They have given the curve as what? R is equal to t square minus 1 into I plus 4t minus 3 into j, 4t minus 3 into j plus 2t square minus 60 into k, correct? Now this is the curve they given. See, sometimes they will give in terms of x, y, z, or they may give in terms of t, parametric equation, right? Now what is that we need? We need to find the tangent to this curve. Remember what is the tangent? Tangent is dr by dt. So find out dr by dt. So it's a very, now I repeat, so why it is dr by dt? See that it's a function of only one variable. So we get the ordinary derivative. So let us differentiate. Differentiation of t square is 2t, differentiation of 1 is 0, therefore you get 2ti plus 4, differentiation of t is 1, this is 0, 4j plus what do you get here, 4t minus 6k. So, ordinary derivative, what is that we need? We need the unit vector in this direction, but what is that before we have to do? We have to find the value of t. So, how do you find the value of t? So, let us keep this as it is, okay. Let us find the value of t. So, let me take the x component of this, t square minus 1, let me okay. So, t square minus 1, let me take the x component, and what is that equal to? They are given, I have to find this, right, at x is equal to 3. So, what do you get? Okay. So, let us do this, 2ti plus 4j plus 4t minus this one in the direction of the tangent of the curve. So, find out the value of t. So, what do you get? 3 plus 1 is 4, t will be 2, okay. So, so what we get? We got the value of t as 2. So, substitute in this, therefore, dr by dt will be, so 2 2s are 4i, then again plus 4j, then, so 4 2s are 8, 8 minus 6 is 2k, right. So, we got the value of dr by dt as this. Now, what we need? We need a unit vector in this. So, find the unit vector n cap. So, this will be what? 4i plus 4j plus 2k by magnitude of this, 4 square is 16, 16 plus 2 2s are 4. So, what do you get here? So, this will be 4i plus 4j plus 2k divided by 20 plus 16 is 36, square root of 36 is 6. Now, what we need finally? We need the directional derivative, which is given by grad phi dot n cap. So, we have the grad phi value as what? I minus j plus 8k, right. So, we have grad phi as this, take the dot product of these two, 4i plus 4j plus 2k divided by 6. So, take the dot product of this, what do you get? 4 minus 4 plus 16 divided by 6. Take the dot product, 4 ones are 4, then minus 4, 8 2s are 16, 4 will get cancelled, 16 by 6 will be 8 by 3. Okay. So, just this is the basic some of the problems which we have on directional derivative. Thank you.